All right, let's start going over these. So I just reshared it one more time just in case. Hopefully you all can see it already. So we want the derivative. So the first thing we need to take the derivative of is 5t cubed. So the 5 comes along for the, already screwed up. 5 comes along for the ride. Bring the power down, subtract 1 from the power. Add that. So remember, with addition and subtraction, you just essentially take each piece and just find the derivative separately. So the derivative of 16t, you can think about that as a power rule if you want to, and bring the power down, but the power is 1, and then you get a power of 0, and anything to the 0th power is 1. Or we kind of presented it as its own kind of rule, where just the derivative of mx is just m. Minus the derivative of 2, which doesn't have a t attached to it, so it's a constant, so the derivative is 0. I'm going through these tiniest bit fast because you should have already tried it, but of course stop me if you need me to. 2 comes along for the ride. Derivative of natural log of t is 1 over t. So if you wanted to reduce this a little, well, clean it up, really. It's not really reducing, but whatever floats your boat. 15t squared plus 16 plus 2 over t. Either of these are perfectly fine. Like, again, I don't really ask you to simplify these. In chapter 4, we are going to want to start simplifying them at least a little bit, because then we have to do some algebra with them, and if they're simplified, the algebra is easier. But in terms of like the quiz that's coming up today and all that jazz, you don't have to simplify if you want. Also, if you know how to do these already, or you've already started to get good at them, you can just, you don't have to write out that all that extra stuff in the middle if you don't need it. If you need it, go right ahead. Use it for the rest of your life if you need it. But if you don't need it, you don't need to write it down. Similar to last time, I'm just going to kind of keep going. I'm going to kind of pause after each one, but just, let me know when you have questions. So for the next one, the 1/2 comes along for the ride. Derivative of natural log of t is 1 over t. Subtract the derivative of e to the negative, that's e to the 0.5t. So that's an e to the kx rule. So we bring the constant, we bring that out front, but then we essentially leave everything else alone anyway. Plus the derivative of 20, which is a constant completely by itself, no variable. Derivative of a constant is 0. So I would personally write it like this, but if you left it as the multiplication, that's perfectly fine. Well, that's still multiplication, but. And then the last one, scroll down a tiny bit. 3 comes along for the ride. Derivative of e to the 2t, you bring that 2 out, but then essentially rewrite the e to the 2t. Derivative of 1/2 natural log of t, we actually just found in the last one. 1/2 comes along for the ride. Derivative of natural log of t is 1 over t. My favorite trick, pi to the 7th. That does not have a t in it, does not have a variable anywhere in it. Pi is a number, so that is a constant. Derivative of a constant is 0. Why do you zoom in? Why? So 6 e to the 2t plus 1 over 2t. Questions, concerns about the warm-up before we move on to our new material for the day? There is something in my eye. All right. So our new rule, I don't want to freak anybody out by saying this, but it is one of the more complicated rules that we have, because it's kind of a rule that uses all of the other rules in it. So it's kind of not just its own separate rule. You kind of have to bring in all of the other ones to be able to do this one too. But we'll figure it out. So first thing we need to do is actually to review a little bit, and we need to review the idea of a composition. So that was back in 1.8. And I know 2 of my classes got to the decomposition piece and one of them didn't. I don't remember which one it was. But anyway, so when we were talking about 1.8, we usually started with 2 functions and we kind of put one inside of the other. What we want to do right here is we want to actually break them up into the 2 pieces. So I can reshare it. Wait, what? It's on someone else's screen. Let me just try resharing the screen and see if that helps. Oh no. There we go. Can you see now, Jake? Yay! All right. What was I saying? So we want to take this and essentially break it up into the 2 pieces. So compositions, we have an inside function and an outside function. So essentially what I'm going to want to do here is I want to essentially write it into 2 different functions. So I'm going to take this and I'm going to have some y equals and then some z equals, where the y equals is going to be the outside function and this one's going to be the inside. And I'm essentially going to put a z in where I'm replacing something. It'll make sense if it doesn't make sense. Anyway, just watch. So we have natural log of 3t. Now, one thing that I suggest if you have trouble figuring out what's the inside and what's the outside function, pretend you're plugging in a number. Say t was 2, and you had to do like each step individually. What would you do to be able to solve this? The first thing you'd have to do is multiply that 2 by 3, and then plug in that result to the natural log. The last thing you did was natural log a number, so that's your outside function, the natural log. So our outside function here would be some natural log of z, where essentially that inside piece is that 3t. So the other one is not necessarily harder, but it's harder for me to explain because of that 5 in the front. If I asked you to let t be 0 and you had to do step by step by step, the first thing you'd have to do is multiply that 0 by 2. Then you'd add it to 3. Then you'd square it. Then you'd multiply by 5. So if you were going by that kind of idea, the last thing you did was multiply by 5. But we technically want to view it as a 5z squared. And I'll also do something in a second that will hopefully clear that up as to why we want to take that squared with us, as opposed to making that part of the inside. So this would be our outside. And well, actually, I can say something about that too, but let me just finish this part really quick. Which would mean that the inside function that the inside function would be 2t plus 3. Side note that I hope isn't going to just cause more confusion. I'm going to say it anyway, but I'm scared a little bit. Technically, I could break this up like this. But doing it like that is not helpful to what we need to do. So the next thing I'm going to write down is hopefully going to clear up why I specifically chose to make it 5z squared instead of just 5z and take the squared into the inside function. So I'm going to write the rule first, and then I'm going to get to the tips. So hold on a second. We'll get there. So essentially, what we're going to be doing is we need to be able to locate these outside and these inside functions, because the chain rule, which is the rule we're about to learn right now, takes the derivative of these pieces separately. So the derivative, the chain rule, what it says is it essentially tells us how to take the derivative of a composition. Now I'm going to write that I wrote in Leibniz notation, and now I'm going to switch to Newtonian, because writing the other side of this rule in Leibniz notation is absolutely disgusting. So essentially, I'm going to write it out in symbols, and then I'm going to write it in words. So we would have f prime of g of x times g prime of x. If I wanted to write that in words, I would probably say something like derivative of the outside function but I just write outside, evaluated at the inside times the derivative of the inside. So wait a second for y'all to get that down. Then I'm going to scroll past the examples. I've got a tip box at the bottom. If any of you have the printed out ones in front of your face, otherwise just write it down on your paper. But anyway, hold on a second. I'll also be scrolling back up to this, so if you don't quite get it, you'll get it in a second. So I want to scroll down past these examples really quick. Go down here. And essentially, we can think about all of the rules that we've already talked about in terms of chain rule. So the power rule, the e to the x rule, and the natural log of z x rule. And we can kind of write it in terms of this chain rule. So I'm going to break this up so I don't run out of space. So essentially, if I want to take the derivative of some z to the n, and here we're essentially viewing z as some kind of separate function. So it's not just an x, it's actually a different function, something more complicated than just an x. Well, the power rule tells us to bring the power down and subtract 1 from the power, and we totally do that. But then our chain rule now tells us that we essentially have to take the derivative of whatever the heck was inside the power. You can also think about this as a g prime of x, since I wrote g of x over to the other side. And so this, you might not get it now, but wait, the examples will hopefully clear some things up, I hope. And we could also say, well, what if we want to take the derivative of some e to the z, where again, now z is representing some type of function. Well, what was the derivative of e to the x? The derivative of e to the x was e to the x, so the derivative of e to the z would start with e to the z. But now our chain rule tells us to take the derivative of kind of that inside piece, that thing that's in the exponent. And then we also had the derivative of the natural log. So say we have the natural log of z, so it's something different than just a singular x or a singular t or something like that. Well, we would have 1 over z from the original rule that we had, but now our chain rule says we have to take the derivative of that inside piece. And again, you can think of that as a g prime of x if you prefer. So one of the larger tips that I can give you, because chain rule is a bit difficult, especially at first, these are kind of your 3 choices for your outside function. Up to a constant. So you might have 5 times something squared, which is why in that one we were just looking at, I didn't just take it to be 5z. I wanted to take it to be a complete power because I need to have that be my outside function. Or I could have 5 e to the z, 5 natural log of z. So if there's just a constant out front, you don't care. But these are kind of like your 3 options for your outside function. So you'll hear me say a lot, I'll say something a lot. So something to a power, e to the something, natural log of something. You'll hear me say that a lot. And it's just because I don't care what that thing is, this rule still holds. But if I want to take the derivative of the natural log of something, I start with 1 over that something and then take the derivative of that something. So let's see, I'll hold on for a second so people can get that down. And then we'll do some examples. Probably won't get to too many because these take a little bit of time, especially if you've never seen it before in your life. Couple more seconds. All right, scrolling back up. Let's get the rule in there. Let's break this off so I don't run out of space. So say I want to take the derivative of 4t squared plus 1 to the 7th. That is ultimately only that outside function is that something to the 7th power. This is essentially a z to the 7th, right? So what the chain rule says is the first thing I need to take care of is the derivative of essentially that something to the 7th power. So, well, how do I do that? That's a power rule. I bring the power down and I subtract 1 from the power. So take the derivative of your outside function, leave the inside function alone. So that's the evaluate it at the inside function part, is you essentially just take care of that 7th power, but leave the inside alone. And then I have to take the derivative of the inside function. So take the derivative of the inside function. It's going to show up back here. Come on. So what's the inside function? The inside was the 4t squared plus 1. So what's the derivative of 4t squared? Well, if I'm doing it out in my full generality, eventually I'm going to start just jumping to 8t in that sort of case, but I'll keep doing the intermediate steps for now. So the other thing I kind of suggest with these is kind of look at it as working inside in. No, what? Outside in. Working outside in, and essentially taking the derivative of each piece along the way. So if I look at this, let me zoom in. This is something to the 7th power. So that like outside thing is that 7th power. So the first thing I need to do is take the derivative of the thing that tells me how to deal with that 7th power, which is a power rule. So I do my power rule first. And then if you want to, you can kind of just like cross it out. So you've kind of dealt with that piece of it, and then just focus on taking the derivative of what you have left. So what do you have left? You have left the 4t squared plus 1. Take the derivative of 4t squared, then take the derivative of 1, and now you've got nothing else to take the derivative of. That specifically can, now you don't need to do that, but it can be helpful to do that kind of crossing out, especially once we get to chain rules inside chain rules inside chain rules. No one can see my face anyway, whatever. So you don't need to do that. I think it's helpful for some people to kind of just start crossing things off, because a lot of times with chain rule, people will be like, how do I know when I stop? They'll just keep going for like days and they don't know when to stop. So that's the one thing that I've thought can possibly help with that, is just trying to focus on what have you already kind of taken the derivative of and what do you have left. So if I wanted to clean this up the tiniest bit, and I could even smush the 7 and the 8 together and get this. But again, any one of those options is completely correct, completely acceptable, because I don't ask you to simplify. Questions, concerns on that one before we do a bunch more? Well, not a bunch because of time, but we're going to do as many as we can. All right. I want to jump over to number 4 then, because number 2 is essentially the same thing. So let's get something slightly different. So first thing, we've got addition in here. So we've kind of got to break it up into 2 pieces. One of the pieces is going to be a chain rule. The other piece is just a normal derivative. So first thing we need to take the derivative of is this e to the negative x squared, and that's a chain rule, because that's not just an x. If it's anything more difficult than if it's anything that's not just an x or a t or a z or a, one occurrence of a variable, if it's got more things in it, it's a chain rule. You can also think of, nope, no, I'm not going to say that. So what's our outside function here? It's essentially e to the something. That is ultimately e to something. That's what I just said. So if I want to do the chain rule here, the first thing I need to take care of is that e rule. So what's the derivative of e to the z? It's e to the z. Well, now I literally wrote z. Whoopsies. E to whatever the heck you have. So if I start doing my little crossy out rule, that means I took care of the e. Well, now I have to take care of the negative x squared. I haven't done anything to that yet. I haven't taken its derivative. Now that gets tacked onto the end. That's the other thing, is that people start doing the derivative of the inside, but they put it in the wrong spot. You do one derivative at a time and just kind of tack them on the end of each other. So now I got to take the derivative of negative x squared, which is negative 2x. Bring the power down, subtract 1 from the power. So now I've taken the derivative of the negative x squared, so I'm essentially done that first entire piece. So now I have to add that to the derivative of 17. That doesn't have an x attached to it, it's just a constant by itself, no variable. Derivative of constant is 0. Personal preference, I like to put everything that's not the e thing in the front and the e thing in the back, but whatever floats your boat. What up? This part? So let me just make this larger. I want to take the derivative of e to the negative x squared. Whoops. Those are my 3 options for my outside function. So hopefully, obviously, I'm in an e to the z case, right? So that rule tells me that the first thing I have to do is actually just rewrite that e to the z. And then after that, I take the derivative of whatever that exponent was. Because just like we had way back when, I know I'm scrolling over God's creation, our original e to the x rule was that the derivative of e to the x is e to the x. So that still holds here. So even though we have now that it's something slightly more difficult than just an x. So that's why that piece pops in there, because that's kind of the first thing we need to deal with is that e rule. And the derivative of e to the something is just e to the something. But then you've got to take the derivative of this something. So let me, since I did colors on the last one, let me just, well, this one's harder to color because I'll just, you know what, I'll just do it like this. Okay. Seven. Let's do some more. Now I unfortunately have to scroll past that rule, but we'll do 2 and 3. That'll probably be well, okay, it's blue now. That'll probably be the last 2 we get to before we have to take our quiz. So 2 is kind of similar to 1, where ultimately we have something to a power, where that something is at 3x cubed minus x. So the first thing I need to take care of is that 5th power. I need to take care of that power rule first. So my power rule says bring the power down, subtract 1 from the power. My chain rule tells me that that inside thing should stay the same at this point. So if I want to, I'm just going to keep doing the little crossy outy and then I'll erase it so that it cleans up. So I've essentially taken care of that 5th power idea. I don't need to worry about that anymore. Now I need to take the derivative of what I have left in my original thing, which is the inside, which was a 3x cubed minus x. And that's just going to get multiplied to the end. So what's the derivative of, I was about to say the derivative instead of the thing, 3x cubed. Bring the power down. The 3 times the 3 will give you a 9. Subtract 1 from the power, you'll get squared. So I skipped the intermediate step there. Minus the derivative of x, which is the one that everyone forgets for some reason. The derivative of x is just 1. Technically a power rule, technically an mx rule. So if we wanted to clean this up just the tiniest bit, well, I'll even go a step further. I'm going to distribute that 5 into the parentheses, so 45x squared minus 5, and then 3x cubed minus x to this 4th. Once again, you don't need to simplify if you don't want to, though I will say for chapter 4, we'll eventually want to, but focus on getting the rules down first before having to worry about the simplification. So sorry, I didn't finish my crossing out. We took the derivative of 3x cubed, we took the derivative of x. There's nothing else to take the derivative of in the original thing. So we're done. Whew. And yeah, let's just The other ones get a little hefty, so let's just do 3. We'll let it sit for a few days in your brain and come back to the last 2 on Friday. So number 3, natural log of q squared plus 1. Well, now I can kind of scroll down and include this. So out of our 3 choices, which one are we kind of in? We're in the natural log case. So the first thing we need to take care of is essentially that natural log rule. So what's the derivative of the natural log of something? It's 1 over that something. So we're going to start with 1 over what's inside the natural log. So that essentially takes care of the natural log rule. Now I've got to take the derivative of what was inside the natural log. What's the derivative of q squared? It's 2q plus the derivative of 1, which is 0. Nothing else to take the derivative of from the original thing. I don't have any more inside functions. I'm done. So if I wanted to, I could clean that up the tiniest bit to this. Once again, unnecessary. No, just questions, concerns on chain rule. We'll hit these last 2 on Friday. And then we have 2 more rules we have to talk about. And those are also kind of, they're not quite as difficult as the chain rule, but they are kind of a similar thing where it kind of like encompasses all the rules. The other rules can play inside of the 2 rules we have left. But the 2 rules we have left follow a bit more of a structure than the chain rule does. The chain rule does follow a structure, but it's sometimes hard to see. Anyway, I'm not seeing any questions. So we'll go ahead and I got to get these people off the screen. I got to stop the recording.